our newest 6 to 36 third prototype.
We're in Taiwan, and yes, that was a real rifle scope. We'll show you the whole thing, what happened, but first, let me tell you how the hell did we even get here. In the beginning of the year, we were at the IWA Gun Expo in Germany and we saw the UTG booth. There were some interesting scopes, something about Integrix, so naturally we were very interested, and after talking with the guys we found out that Leapers, UTG and the new brand Integrix are all under the same company, so they invited us to the factory. The deal is that they will pay for our trip if we come there, do a factory tour and post a video about it. The trip begins. A quick drink for the start, we go on a plane, drink on a plane, we stop at Dubai for a couple of drinks. The other plane was the A380, super big, super awesome, super comfortable, of course we need to cheer on that, and we land in Taiwan. The trip was super fast, I don't even remember half of it. And one hangover later, we are here at the factory. This is Margaret, head of product marketing at Leapers, and she'll be our guide for today.
These are Japanese-made FANUC machines, and over on the left over there, we have a wire EDM machine, which is how we make prototypes really quickly.
First floor of the factory is dedicated to prototyping, measurement and quality control, laser engraving, and production of UTG and OEM parts. One of the rooms is specifically dedicated for tooling and machine parts. Here you can find all sorts of drill bits, boring tools, drilling crown, twist bits, auger bits, everything, from the smallest to the biggest possible. But what impressed me more than modern tooling is the fact that they still have an old-school machining shop with manual drilling machines, lathes, and other hand tools that they still use in the late stages of prototyping and product development. Even in the age of computer modeling and high-end 3D printing, you still need skill and manual labor to get the best results. Here we can see the CNC machines producing different kind of UTG products. This one specifically is the rare iron sight for an AR, and it's constructed from a forged blank that is machined to the final proportions. What we're not allowed to show here are a couple of OEM products that are made for certain high-end companies that you would probably never guess are produced here in Taiwan. Next to it is the production of the newly established UTG line of magazines for the AR-15s, AR-10s, AKs, Glock handguns, and I think many more are coming. As you can see, the production line is almost completely automated with the use of robots and certain automatic machines, because the guys tell me that in the long run, this is the only way to produce good, reliable magazines for a decent price.
This Bumblebee is our 6-axis robot, and we've automated the processes to apply the windows for our 308 and our AR magazines. Our new AK windowed magazine, for example, we haven't automated yet because we want to increase the quantity before we optimize to that level.
I'm impressed by the level of automation that we see here. The machine behind me is made just for this purpose. It cuts the nibs of the magazines and does it automatically. Quite impressive. Hey, what's the deal with these?
This is a funny Taiwanese snack. It's called guai guai, which in Chinese means good boy. And so the tradition we have here is that we take these snacks called guai guai, we put it on the machine, and we're telling it to be a good boy, don't break, please don't break.
When moving to the upper floor, we stop in the middle of the stairs. These small cracks are a harsh reminder of a massive earthquake that hit Taiwan just a couple of days before we came here. It was a magnitude of 7.2 on the Richter scale, and that's crazy. Like, if that happened in Slovenia, half of our buildings would be gone. But here, everything is built different. As this is a common occurrence in Taiwan, earthquake-resistant construction is a must here. Now we finally come to the optics. If you want to design a good rifle scope, you first have to know your competition. That means that you need to analyze and compare all of the high-end scopes, and that's a lot of them. Like really, I mean a lot. Since you have so many scopes to compare, which one is the best?
I knew you were going to ask me this, and it's a little bit of a trick question. I'm not going to say Integrix, but I'm not going to say anyone else's scope either, because there's so many dimensions to a scope. It's very hard to say that a single scope wins on everything, from look to reticle preferences to field of view to resolution. If I'm a hunter who's in a wide plain, then I will care about the field of view the most. If I'm a hunter that's in a forest that has a lot of foliage, then I'm going to care about the contrast more than the field of view. So all these things are difficult to quantify as single, this is the best scope, but you can choose the best scope for your application. And what we try to do with Integrix is deliver a really balanced product. So we're looking at, how is our resolution through the center on axis? We're measuring 50%, 90% off axis to the edge. And we're making sure that your image quality is really good throughout the whole thing. You might pick up a different scope that maybe has the very best image quality right in the center, but blurry on the edges. So it really kind of depends what you're doing and how you choose your scope.
Now that we figured the characteristics and capabilities of the scope that we want, we can start with the actual development.
We're here at the UTG Taiwan R&D Center. Running business is all about people, process, technology. I always like to create an open environment, be here on the ground with the guys. We're designing the professional products designed by professionals, made by professionals, for the professionals.
We'll be following the production of their flagship optic, the IX8, which is a first focal plane LPVO with 1:8 magnification and 34mm tube.
This is our simplest scope for Integrix, and it's close to 140 parts. So it's quite a complex thing to assemble.
The scope outer body is machined from one solid piece of aluminum stock. This isn't the most efficient way of production because there is a lot of waste material, but it's the best way to produce a strong, rigid outer body of the scope. Fun fact, turrets are machined separately and then threaded on later. It did fool me because when the parts are joined together, the surfaces are so precisely machined that there is no visible seam.
This is a multi-axis mill-turn machine, and this is how we create the most precise part in the scope, the erector tube. It takes 12 minutes end-to-end to create, and the precision needs to be on point, the concentricity of the circles too, within 0.005 millimeters or 5 microns, and a human hair is 70 microns.
We learned that the most important part in production of erector tubes is not the precise machining itself, but quality control. In this room, they check and double check each and every part, first with just simple go, no-go gauges, and then with more advanced machines like this 2D comparator that besides dimensions, also looks at the concentricity of the part. The precision is crucial here because the erector tube does multiple functions in a scope.
There's 4 lens sets, the reticle, the 2 lenses that move to change your magnification, and 1 fixed. This needs to be held to a super tight tolerance, and when this moves, it needs to be smooth at the same time. When these lenses are further apart, that's for a closer magnification. Low magnification, when they're closer together, it's a higher magnification.
So this ringy thingy on the end of the erector tube is actually what holds it in place, but also allows it to move up and down and sideways. And when you are actually adjusting your turrets for windage and elevation, you are moving the whole thing inside your scope.
All of our lenses overall are either German shot glass or Japanese O'Hara with multi-coating on both sides to maximize your light transmission.
What's important to mention here is that the Integrix guarantees 92% light transmission through all of their scopes, which is more than even some of the most expensive scopes on the market today. They have a very expensive German machine just to double check the high-quality German lenses.
This is the ocular lens system, which is what your eye's looking through in the scope. And this machine measures the lens thickness. There's 3 lenses inside, as well as the air gap to verify everything's correct.
In the same room, we can also see hardness testing, measurement of certain tool dimensions, and another segment of quality control. It's always interesting to see how many parts are rejected for the smallest imperfections that I would barely notice. Next to the table is another expensive machine that's used for super precise measurements in all dimensions. There are more than 140 parts in a single 1:8 scope, and now that we have all of them here, let's move to the assembly. We're entering a clean area, so we still have to wear some protection. We have these mats to capture dust. We're trying to not introduce too much dust to the area.
Normally, a clean room for biotechnology or medical parts is around class 1000. But these clean tables that we've installed are even upgraded from that to class 100, which means that within 1 minute and 1 cubic meter, there cannot be more than 100 particles of 0.5 micron size. Anything bigger than that, definitely none at all. 0.5 micron is 0.0005 millimeters.
What's amazing is that I can barely feel any air moving.
It's laminar flow, and it's very important because you're also dealing with very delicate parts, and you don't want the air to disrupt your processes. And just for context too, if you didn't have the clean table running, within this amount of space, we would have 200,000 particles
Of dust.
of dust. So these are 2 different processes right now, and what you're looking at is our erector system that we were looking at earlier, and the one that controls your magnification. This is the most precise part of the scope, and what she's doing over here is fitting the erector tube with the erector housing outside of it. These 2 pieces need to be concentric, and the tolerance is super, super low, where one of them, the housing, can only be 0.01 millimeters larger than the tube inside. It cannot be more than that larger. So she's fitting, making sure that they fit very well together and very smooth. So once you fit the erector tube inside the housing, this is where we start to assemble the very small lenses inside. So right now, this is Dora, our lens cleaning expert, and she's taking the reticle and she's cleaning it very carefully, make sure there's no dust, no damage, no dents. We also double check this on the microscope. Our reticles are etched, and you apply a reflective coating, so then that's how the illumination works.
So what's happening right now is that they already had set up a bad reticle because obviously they don't want us to destroy it. But I couldn't spot any imperfections, but that one was rejected by QC. So now they got a really bad one. So just they can show us what they are looking for and what is a bad reticle. If we look closely at the corners of the reticle, we see some imperfections. This is where the reflective paint did not fill in completely, and this is enough to get it rejected. Just to give you a perspective how tiny this reticle really is, we have put it next to a human hair. Now the microscope cannot focus on both at the same time, but you can still see the big difference in thickness. Here we see the assembly of one of the turrets. Now this was done specifically for our use, so we can handle it, test it, but this will not go in a scope. In normal production assembly, everyone needs to wear a minimum of gloves and a mask, and there's much more steps for quality control even here.
This measures torque. So we actually made a custom kind of fixture to measure the torque of each click. And we spent a long time optimizing exactly how much resistance and how tactile it is.
When the scopes are assembled, they go to the last step of production, which is nitrogen purge. This is achieved by putting the scopes in a special chamber that will create almost perfect vacuum and then fill up with nitrogen. This cycle is repeated 3 times to make sure that only the nitrogen stays in the scope. This is important because nitrogen is an inert gas, will not react with anything, and also because there is no moisture, there is no possibility of the scope fogging up. A finished scope gets the last laser engraving as a seal of approval.
This is called a collimator, and it lets you mimic light coming from different distances, like your target is at a different distance from your scope. So this whole room is our measurement room, which is really important for us when we're building in-house. We want to verify that we're hitting what we're trying to hit, and we want to benchmark against the very best and measure it with numbers and prove it. So this allows us to measure contrast and resolution, as well as the magnification, if it's a true 1x, if it's a true 20x magnification, the exit pupil diameter, and the exit pupil distance. You want to make sure that that's constant for your eye box as you change your magnification as well. We use the USAF 1951 military standard to be able to measure the contrast and resolution, the MTF. What we do is we do it across the field of view. So we try to mimic different conditions for your pupil size, basically mimicking your aperture at noon, evening, at different times of the day, as well as on axis through the very center as you're looking through the scope, 50% off, as well as 90% off. So we're really looking at edge-to-edge contrast, and we're measuring that. We take one of the really great competitors in this magnification range, and we go head-to-head, and we're going off-axis around 50%. We can prove and measure that we are 20% better resolution in that condition.
For more practical testing, they have an indoor range where they can simulate different times of day by changing the lighting. Measurements and numbers are great, but we want to give you a visual representation. For example, here we have the Integrix 6x36, the new prototype, which boasts with one of the biggest fields of view at any magnification in the industry. Next to it, we have set up a top-tier scope, and both of them are at the 8x magnification. There is a large scale on the wall, and we can see Samo there watching some stupid YouTube videos. Now, both of the rifle scopes are set to the same extreme left point, the number 3 over here. When we look to the right side of the Integrix scope, we can barely see Samo, and in the other scope, we cannot see him at all. If this doesn't make the point, I don't know what will. This is a temperature and humidity tester. This machine can produce a wide range of temperature and humidity conditions. We will use it to stress test one of the scopes. In our case, we'll bring it down to the lowest extreme working temperature, and to show our point, we'll put an orange next to it. The scope is in a normal working condition, the battery is inserted, and the reticle is turned on. We add an orange just to show you how extreme this test really is. The scope and the orange are now at -40 degrees, and when we take them out of the machine, we can see that the outside air starts to condense and freeze on contact. Such an extreme low temperature will make even soft materials like rubber brittle. We were surprised that the illumination still worked because some of the batteries are not rated for these temperatures. What was even more mind-blowing was that all of the turrets and adjustments worked. This indicates to me that there had to be some special thought and design behind this, because even just using normal grease and lubricants will make the moving parts inoperable at these temperatures. Just to show the point how cold -40 really is. This one is room temperature, very soft, normal. This one was next to the scope. Oh shit. It's like a rock. What we did next is not a standard test. Instead of waiting and giving the scope and O-rings time to come to a room temperature, we just dunked it directly into water. This machine can put water under different pressure, simulating different depths, so it can be used for waterproof testing and different IP ratings. Nothing happened, which is good in this case because the scope stayed waterproof and the illumination still works. It passed this test with flying colors.
These are assembled, passed all of our quality checks, And part 2 is now taking these, shipping them from R&D in Taiwan to headquarters in Michigan. And there we'll put them through the final rounds of testing.
So this is the prototype of the 6 to 36 magnification, their new model, but since it has some imperfections, they said that we could stress test it with a drop test.
Well, I think it might be hard to break actually.
You want to bet?
Let's go.
It's still working. It still works. We did the lab testing and we are super impressed by the production and the quality of the scope, but now we'll take one home, put it on our guns and test it properly in a real world environment. Thank you very much. Thank you, David.
Thank you.
Thank you, Margaret. Thank you for having us. This was amazing.